The Wright brothers called their bold new concept wing warping. They set out to test their theory by building a 5-foot biplane kite out of bamboo and paper.
It had cords that ran from the wings that crossed to sticks that Wilbur held, and as he moved those sticks, the wings warped, and he was able to bank the kite.
Up until that time, no one really had control over the kites. It was just at the mercy of the wind. But here he was, he's able to make a descent and climb on command.
700 miles from Dayton, a remote village on the outer banks of North Carolina seemed ideal. Its sands promised soft landings, and its solitude ensured the secrecy the guarded Wrights demanded. Kitty Hawk would become a turn-of-the-century version of Area 51. September 1900. The Wright brothers' quest for flight began in a place so remote that no one in the closest town could tell them how to get there. Kitty Hawk was as obscure as the two bicycle makers who hoped to make history there. The glider's control system featured two elements. A forward-mounted elevator enabled the pilot to nose up or down, and the innovative wing warping system, which was linked to a foot-operated T-bar.
If you pushed back with your right foot, then that would warp the wings to help you turn to the right. And if you pushed with your left foot, then that would help you turn to the left.
The Wrights began by flying the glider as a tethered kite, with lines running to the ground to operate the controls.
The elevator worked pretty good. The wings worked relatively well. I'm based upon all the engineering knowledge at the time, and the thing just didn't generate as much lift as it should have.
So that year, they were unable to really fly that glider as a true manned glider. At one point, they did enlist one of the local children, Tom Tate was his name, to get on the glider, and they flew it as a kite with him on board.
The Wrights returned to Kitty Hawk in 1901. They assembled a new, larger glider in a hangar they erected themselves. Its wings were 22 feet long and 7 feet wide, with a surface area almost double their original model. As they had done the year before, the Wrights began by flying the glider as a kite. Unlike any inventors before them, they chronicled every step of their progress, or lack of it, with a wind tunnel. They crafted it from a wooden box that held laundry starch. Power was supplied by a one-cylinder gas engine used to run the bicycle shop's machine tools. It drove a fan that created a 23-mile-per-hour wind stream.
Now you'll notice as you look into the wind tunnel, this would straighten the wind and give it a nice smooth flow all the way through. Now at the far end of the wind tunnel, the Wrights put a balance. That balance is how they measured lift. This balance was a very simple and crude affair. It was made of old bicycle spokes and hacksaw blades.
For each wind tunnel test, the Wrights vertically mounted a miniature wing, or airfoil, on the balance. Each airfoil had its own unique curvature and shape. Mounted near the airfoil was a series of flat plates with known values of drag. By carefully measuring the difference between the airfoil's effect on the airflow and that of the flat plates, the brothers could calculate the airfoil's lift. Over 3 months, they tested nearly 200 different airfoils. The Wrights, like all flight pioneers, knew that a wing produced lift by creating reduced air pressure above and increased pressure below. Their challenge was to discover which shape would create the greatest degree of lift.
The problem was they were generally pretty symmetrical. The high point was right in the center. What they found was that you really want to have the highest part about a third of the way back, not halfway or not way up front like they did on their 1901 and 1900 gliders.
Armed with their breakthrough findings, the Wrights returned to Kitty Hawk in August 1902. They cannibalized their 1901 glider and crafted a new model. They not only modified the curvature of the airfoil, but made the wings 10 feet longer and 2 feet narrower. They also added a fixed vertical tail, reasoning that it would add to the glider's stability. Finally, the brothers re-examined the glider's control system During their first free glides, the Wrights discovered that the new craft's wings generated precisely the lift they had calculated. The new tail seemed to solve the problem of the glider reversing course during a turn, but a vexing new problem arose. At times, the glider slipped sideways, tipped on its low wing, and spun into the sand. Every flight seemed fraught with risk. In September 1902, the Wrights faced their closest brush with disaster.
Orville was flying along, and the glider started to go out of control.
At the Wright brothers' camp, it was time for their unique approach to problem solving.
They had a good time arguing about these problems.
After a while, they would generally come to an agreement. But by doing this, they would really look at every angle, every side of an issue.
The unusual procedure yielded two inspired suggestions. Orville proposed that they hinge the fixed vertical tail of their glider to make it movable. Wilbur added a new wrinkle. He suggested they link it with pulleys to the wing warping system. With one shift of the hips, the pilot could twist the wings and turn the tail simultaneously. On October 10, 1902, the Wrights were ready to test their revamped glider. 4 years of tenacious calculation and painstaking work had boiled down to one critical moment. Wilbur manned the controls. Orville and a Kitty Hawk local aimed the glider directly into the stiff wind.
Wilbur throws his hips over to induce a roll to the right for a coordinated turn. And for the first time in history, we have true flight.
The Wrights flew the revolutionary craft on 375 flights that October, the best lasting 26 seconds.
They were able to fly in any wind. They were able to stay in the air for long periods of time. They were able to fly over 600 feet on some of those glides.
Still, they needed a light yet powerful engine, effective propellers to produce adequate thrust, and a sturdy new frame to carry the weight and withstand the vibration. The craft the Wrights would call the Whopper Flying Machine would be a fusion of innovative breakthroughs made with unparalleled speed. Wilbur and Orville crafted their own engine with the help of their chief bicycle mechanic, Charlie Taylor. They cast the crankcase from aluminum, which had only become commercially available in the past decade. The rest of the engine was primitive, even by turn-of-the-century standards. It had no fuel pump, carburetor, or spark plugs. Still, it produced 12 horsepower and weighed only 179 pounds. As Taylor made the engine, the Wrights struggled with an even greater challenge: the propellers. To that time, flight pioneers had assumed that an aircraft propeller would function much like a ship's, pushing air instead of water backward to drive a plane forward. Months of study convinced Wilbur otherwise.
Wilbur's idea that was very different was that a propeller should be a wing on its side traveling in a spiral course and producing lift horizontally or producing thrust.
Applying their revolutionary theory, the Wrights carved two spruce propellers.
They could get by with a less powerful, lighter engine with the two propellants.
Compared to their gliders, the Wright Flyer was massive. The 1902 glider weighed 120 pounds. The Flyer weighed 605. The engine, comprising nearly a third of that weight, was mounted to the right of the pilot. Since it outweighed each of the brothers by 34 pounds, it made the aircraft unbalanced. To compensate, they added 4 inches to the wing on the heavy side to create more lift. It took several weeks to assemble the Flyer and ready it for its critical first flight. They feared they were too late. On December 8th, Langley invited the press to witness the launch of his great aerodrome from a houseboat on the Potomac River. When the aerodrome was catapulted from its launch rail, its rear wings collapsed. The plane plummeted in pieces. The pilot escaped unhurt, but the disaster made Langley a laughingstock.
If this scientist, a man of international renown, could not successfully develop a flying machine, then the likelihood was no one could.
9 days after Langley's failure, the Wright brothers prepared to fly in the face of conventional wisdom. Since the Flyer had no wheels, they built a 60-foot launch rail out of 2x4s laid end to end. The aircraft's skids rested on a small dolly. The Wrights recruited several members of Kitty Hawk's life-saving team to act as their ground crew. They instructed one of them, John Daniels, to stand ready with their camera. A toss of a coin determined that Orville would take the controls. At 10:35 a.m., Orville boarded the Flyer and the engine was started.
He releases that whole back wire and that craft starts down the rail.
The Flyer rose gracefully, then followed a meandering up and down course as Orville struggled with the elevator. After 120 feet, it darted into the sand.
John Daniels was so excited about seeing the aircraft lift off the rail that he wasn't even certain if he had squeezed the shutter bulb to take the photograph.
Daniels needn't have worried.
Initially, it doesn't look like there's a lot there, but if you really look at that, it's much more detailed than you think. You can see the launching rail. You can see the little dolly that the plane was on. You can see the tools they used that day, a shovel to level the ground. You can see a little grease bucket that they used to grease the rail that the plane ran along, a dry cell battery to start the engine. A professional photographer could not have done it any better than John Daniels did that day.
An hour after their first flight, Wilbur piloted the second, covering 175 feet. Orville flew the third for 200. Then, on flight number 4 that December day, Wilbur kept the Flyer aloft 59 seconds, soaring 852 feet. Minutes later, a gust of wind overturned the Flyer and sent it hurtling across the sand. The damage was beyond what they could quickly repair. It would never fly again. The Wrights' unique talents had made flight, humankind's impossible dream, a reality. But their mistrust of others would nearly cost them the credit for it.